Hey everyone, and welcome to today's Explainer. If you're a future coder or a computer science student just starting out, you are in exactly the right place. Today, we're unpacking the absolute secrets of writing truly professional Python code. We're leveling up from writing basic scripts to mastering the ultimate building block of serious software engineering, functions. Here's a quick look at our syllabus for this masterclass. We're going to cover divide and conquer, the anatomy of a function, how to avoid the notorious variable scope trap, passing and returning data, and we'll wrap up with using pre-built modules. All right, Section 1, Divide and Conquer. Let's tackle what is honestly the biggest nightmare for any junior developer out there. Picture this. You're staring at a single monolithic script. It's 10,000 lines long. You hit run, an error pops up on line 8,432, and finding the actual source of that bug, it feels literally impossible because every piece of logic is just tangled up with everything else. We call this spaghetti code, and trust me, it is the absolute fastest way to burn out as a programmer. But here is the perfect solution, breaking that massive, terrifying task down into smaller, bite-sized pieces. Instead of one giant, tangled mess of statements, the program gets divided into isolated functions. The main program just calls on smaller, specialized workers to get the overall job done. So, looking at it side by side, we contrast the spaghetti code of a monolithic program against the clean, isolated design of a modularized program. Think about a real-world payroll app. You wouldn't calculate everything in one terrifying block, right? You'd have one dedicated function to get the hourly rate, another one just for taxes, and a completely separate one to actually print the paycheck. Honestly, I can guarantee these 5 benefits of modularization will completely save your sanity. Plus, they'll speed up your development time like crazy. First, simpler code. Small functions are just inherently easier to read. Second, code reuse. Write the logic once, use it 100 times across different programs. Third, better testing, because you can test each function individually and easily isolate bugs. Fourth, much faster development. And fifth, easier teamwork. You can assign different functions to different programmers without anyone stepping on each other's toes. To actually build these modular programs, we use a process called top-down design. You basically start by looking at the biggest overall task. Then you step down, breaking it into subtasks. You take those subtasks and break them down even further until you literally can't break them down anymore. Only when you reach the very bottom do you actually write the code for those tiny pieces. It's a structured way of thinking that completely cures that spaghetti code problem we talked about earlier. Moving right along to Section 2, Anatomy of a Function. Let's see how we physically build these life-saving modules in Python. By definition, a function is simply a grouped block of code designed to do one specific job, and do it really well. Think of it like a mini program living inside your main program. It just hangs out, entirely out of the way, until you explicitly call on it to do its job. To write this out in Python, we use the def keyword for the function header. That's followed by the name of our function, some parentheses, and a colon. Then you strictly indent the block of statements below it. That indentation, absolutely critical. It tells the Python interpreter exactly which lines of code belong to this specific function. To make it run, you just call the function by name elsewhere in your script. Okay, Section 3, the variable scope trap. Pay close attention here, because this is where almost every single beginner creates critical bugs that take hours to track down. Whenever you assign a value to a variable inside a function, you are creating what's called a local variable. Local means it belongs exclusively to the function where it was created. It is completely hidden from the rest of the program. It's basically the Vegas rule. What happens inside the function stays inside the function. If your main program tries to snoop and print a local variable from another function, Python is going to immediately throw an error. We call this visibility a variable's scope. Think of scope as the strict boundary lines of where a variable is actually allowed to exist. Understanding this is your absolute best defense against broken logic. A local variable's scope is purely the function it belongs to. Nothing outside can see it. Actually, even code inside the function that appears before the variable is created can't see it either. Because these local variables are hidden securely within their scope, we can have 2 totally different functions. Let's call them a Texas function and a California function. And each can successfully use a local variable named birds. They won't interfere with each other at all. Texas can have 5,000 birds, California can have 8,000 birds, and the Python interpreter never gets confused because each bird's variable is completely isolated in the computer's memory. So here is the crucial takeaway. Avoid global variables at all costs. A global variable is created outside of all your functions, meaning it can be accessed by anything. Using global variables is like leaving your front door wide open in a bad neighborhood. Any stray line of code can wander in, change a value, and make debugging a total nightmare. Always, always stick to local variables. All right, Section 4, passing and returning data. Since we're strictly avoiding those global variables, let's explore how we actually move data safely in and out of our isolated functions. When you call a function, you can feed it specific pieces of data, which we call arguments. An argument is just data sent into the function. Inside the function's parentheses, you put parameter variables. Think of these as catcher's mitts. They literally catch the arguments you pass in. So if you're looking at code like def show_double number, that word number inside the parentheses is the parameter catching your argument. In Python, this acts as a one-way street, which is known as pass-by-value. The function reads the value you passed in, but it can't alter the original variable's value back in the main program. It is a highly secure, isolated way to hand off your data. But what if we actually need data back out? Well, we contrast that pass-by value for our input with the return statement for our output. To get data back, we write a value-returning function. It runs its code, calculates a result, and then uses the return keyword to send a value right back to the exact statement that called it. This turns our function into a really powerful two-way data processor. Finally, Section 5, using pre-built modules. Once you master writing your own functions and managing variable scopes safely, you unlock the ultimate superpower, using modules built by other expert programmers. Python's standard library acts like a massive black box toolkit for you. You just import a module and boom, you suddenly have hundreds of new functions at your fingertips. For example, import the math module and you instantly get access to functions like sqrt for square roots, hypot for finding a hypotenuse, and ceil for rounding up. You don't even need to know the complex math behind it. Just pass in your arguments and let the black box do the heavy lifting. Or think about the random module. By typing import random at the top of your file, you can effortlessly simulate dice rolls or coin flips. Calling random.randomant securely generates a pseudo-random integer. It's an absolute must-have for building games, simulations, or statistical programs. These pre-built modules are going to save you countless hours of reinventing the wheel. So now that you have the tools to write clean, modular, and bug-resisting code, and you know how to leverage the immense power of Python's built-in libraries, the only question is, what complex system are you going to conquer first? The tools are right there in your hands. Get out there and start building.